Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we are doing another worksheet. It's called Ionic Bonds number 4. This is a summary of what we have done thus far. And I'm hoping that you have previously watched the other videos within this play set. Uh, look at my playlist and check out the other previous videos. Those are very important before you move on to this one. So I will assume that you have watched the previous videos. Also, I will assume you know your periodic trends on ions and charges from the periodic table. And furthermore, you should also have this worksheet out with you as well, which is the charges on ions and oxidation numbers. You should have this handy as well. It's going to be really important. I am the Crazy Hat Chemist, and this is where you come to learn all the things that are necessary for real chemistry. Not that fake stuff. Oh, no way, no how. This is where the real chemistry is. At least this will give you the foundation of the real chemistry. All right, so without further ado, let's get moving. We're going to do ionic bonds worksheet number 4. This is a little summary of things, and we're going to be doing transition metals and non-transition metals, as well as polyatomic ions and not. So it's a combination of a lot of ionic bonds. Here we go. Without further ado, let's get moving. So we have 3 columns here on this worksheet. One of them is called the systematic name. Okay. And that is what we are going towards now. And then we also have the common name. And that is what when I went to school, that's what we worked with. And then we're going to have the formula of that compound. It will be an ionic compound. So let's see if we can fill out these 3 columns for each one of these. So it says iron Roman numeral 2 nitrate. I will assume that you know your Roman numerals. Without doing that, then that's a problem. You should probably watch another video on just your Roman numerals and probably need to make one of those. Um, all right, so with a Roman numeral 2, that lets you know that the iron, which is the cation, has a 2 plus charge. Okay, and hopefully that will work. And iron and ferrous go together. So iron Roman numeral 2 and ferrous, they go together. The OUS of the common name, that OUS is always the lower charge of the 2 charges if there are 2 charges. And so what one would do is write Fe, and that's a 2 plus, and then you have to know the polyatomic ion nitrate, that is NO3 with a -1. And what we do here is we kind of hide something. And the part that we hide is the following. So what we're going to do is we're going to circle this number and circle this number. And so what we're going to do is really hide that plus and hide that minus. We're going to take the bull by the horns. That's a 2 on your index finger, a 1 on your pinky. That's a 2 for the cation and the 1 for the anion. So you take the bull by the horns, you flip those numbers and you bring it down. That means that this 1 will come here and this 2 will come there. And that's why we write this formula of Fe, and there's a 1 right here, and then NO3 with a 2 on the outside. Well, we don't write 1s, and that's why we scratch that out and we pencil that out. And then there's our formula, FeNO3 parentheses and a 2. Why do we need the parentheses? Because the number outside the parentheses is greater than 1 that has not been reduced. All right, that's the example problem right there. So let's continue on and see if we can do some more. The next one is silver and then sulfate. So the silver is the cation, the sulfate is the anion. So cations are positively charged, anions are negatively charged. You should review my previous video so that you understand that. I'm going to either look at the periodic table and understand and know what the charge on the silver ion is. We can do that real quick. There is a diagonal pattern right here and a downward section like that. And the charges of these, it would be silver 1 plus, zinc 2 plus, aluminum 3 plus, and cadmium and zinc are in the same column at 2 plus. So that means that my silver is a 1 plus. Alternatively, you should have this charges on ions and oxidation numbers, this piece of paper right here. And if you have that, then you should be able to find the silver ion on this. It is in the 1 plus category. It is a monoatomic cation. And here it is, Ag1 plus, that is the silver ion. All right, perfect. So now I know the silver ion, that's Ag1 plus. Now I need to find sulfate. Sulfate must be a negative charge. Why? Well, it's an anion. So that means that you are going to either look on this section right here, which is -1, -2, -3, or you are going to look on this lower section where there are polyatomic ions. And the polyatomic ions here are, excuse me, the polyatomic ions are in this lower section here. They are blocked off into categories. That is -1, -2, -3. There is only one polyatomic cation, and that is called the ammonium ion, and that is written right here. That is the only polyatomic cation. The rest of them are anions. And what are we looking for? Well, we are looking for sulfate. So we're going to have to find sulfate. Sulfate just happens to be in the 2- category, and it is right here, sulfate. So that corresponds to a polyatomic ion formula of SO4 2-. So what is a polyatomic ion in the first place? So a polyatomic ion is an ion composed of 2 or more covalently bonded atoms. So there are 2 capital letters and there's a charge. That's a polyatomic ion. So I'm going to write down SO4 2-. That is the sulfate ion. So I'm going to write that down right here. That is SO4 2-. What I'm going to do is I'm going to circle the cation and its charge. I'm going to circle the anion and its charge. I'm going to pencil out the plus. I'm going to pencil out the minus. I'm going to take the bull by the horns and flip and bring it down. And so the bull is right there like that. My index finger is the cation, and in this case, it is the 1 plus charge of the silver. Then my pinky finger is the anion and has the 2- charge of the sulfate. So I'm going to take the 1, I'm going to take the 2, I'm going to flip the numbers, and I'm going to bring them down. So what that does is that takes this number and brings it down over here. That takes this number, brings it down over here. So I'm going to have the formula for silver sulfate as Ag, and then the number that is brought down here is a 2. I'm going to have SO4. And I'm going to do this in pencil here, and I'm going to dash it. So dashed, and then a 1. Do I write ones? No. Consequently, I do not write these dash parentheses. I'm going to leave that there in pencil, but those do not belong there. Only the blue and the red pin marks do actually belong in this formula. Okay. All right. By the way, just to make sure that everybody is on the same page, the reason this is actually a shortcut, taking the bull by the horn, flipping, bringing it down, but really what you're actually doing is you're getting a net charge on an ionic compound of 0. So that means that you have a silver that's a 1 plus and a sulfate that is a 2-. You need 2 silvers for a total of a 2 plus charge to equal 1 sulfate of a 2- charge. When I sum up the 2 plus and the 2-, I get a net charge of 0. And that's why there's 2 silvers and 1 sulfate to get a net charge of 0. Really, that's the real rule. Okay, I'm giving you a shorthand abbreviated method. Let's move on to the next one, which is called sodium hydroxide. Oh, by the way, this middle section here is X'd out for the common name for silver sulfate because silver only has a single cationic charge. That is, it's a periodic trend of a 1 plus only. It is a monoatomic ion. It only has a 1 plus. There is not 2 charges like on iron. So we'll get to more of those as we move through this worksheet, if that doesn't make sense. There's a cation and an anion for sodium hydroxide. Sodium. What is sodium? Well, I'm going to find sodium on my periodic table. Sodium happens to be in group number 1 or 1A. Consequently, that has a 1 plus charge, as does everything in group 1 or 1A. Furthermore, you can find it on my ion sheet. That is, here is sodium, and it is an Na1 plus. It's a monoatomic cation. All right, fantastic. So I'm going to write that down. That's going to be Na with a 1 plus, just like that. Now, hydroxide, I am going to first attempt to find it right over here in the monoatomic anions, but I do not find hydroxide. Even though all of these end in an "ide," it is not there. I do not look in the transition metal cation section, but I will look in the polyatomic ion section. So in the polyatomic ion section, I will be able to find hydroxide, and I will highlight that here for you. Here is hydroxide. It's in the 1 minus category, and it is an OH with a 1 minus. That is hydroxide. So I'm going to write that down. Write OH and a 1 minus charge for hydroxide. So I'm going to do the same thing that we did before. We're going to circle the cation, circle the anion. We're going to pencil out the positive charge, pencil out the negative charge, and we are going to take the bull by the horns. That's a 1, that's a 1. I'm going to flip those numbers and bring it down, and I will get the following formula. That will be an Na and an OH. And I'm going to pencil in this number right here. That's a 1. There's a parentheses around every polyatomic ion, and then a 1. All right. This 1 does not belong there. Consequently, the parentheses do not belong on there, and that 1 does not belong on there. Sodium is a monoatomic cation, and there is no common name for that. So I don't have a common name for this, and that's why it's X'd out. All right, so that was problem number 2, effectively, since the first one was already done for you. Let's see if we can move on. We're going to do the next one, and that is gold, Roman numeral 2, and cyanide. Gold will have a 3 plus charge, because if we know our Roman numerals, that Roman numeral 3 is for a 3 plus charge. I need to find gold with a Roman numeral 3. Now, if it has a Roman numeral or an ion that is a common name, then I will find it in what's called the transition metal cation section on my handout. So on my handout, there are transition metal cations. These are ions that are cations that have more than one charge. They have common names, they have systematic names. And so gold, Roman numeral 3, is right here. What does that correspond to? Au 3 plus. What does it correspond to? Auric. So auric is the common name, and gold Roman numeral 3 is the systematic name. And then Au3 plus is actually what the formula is. So I'm going to write Au3 plus, and I'm going to write auric, Auric, and then also cyanide. Cyanide, cyanide. So the common name for gold Roman numeral 3 cyanide is auric cyanide. All right, now I need to find cyanide. Cyanide is a polyatomic ion. Let's see if we can hunt that down over in our polyatomic ion section. And that is right here at cyanide. That corresponds to the following formula of capital C, capital N, 1 minus charge. So I'm going to write that down as well. So Cn, 1 minus charge. Again, I'm going to do the same thing that we did before. We're going to circle this number, that is the cation and the anions, cross out the plus, cross out the minus, take the bull by the horn, flip, bring it down. The index finger is a 3, the pinky is a 1. This number comes here, this number comes there like that. I'm going to have AuCN, and then this is going to be a penciled in 1, which does not belong, but there is parentheses around a polyatomic ion, and those parentheses stay there because the number outside the parentheses in this case is a 3. Fantastic. All right, let's move on to the next one. We have potassium chromate. Okay, so potassium, I need to find potassium. That happens to be right underneath sodium on our periodic table. So that is right here at potassium. That's a K, and that has a 1 plus cationic charge. Alternatively, you can use this sheet of paper and you can find potassium in this 1 plus category. There's potassium, and it is K with a 1 plus charge, just like what we got from our periodic trends. So that's going to be a K with a 1 plus charge. Now notice this is not a transition metal cation. It does not have alternate charges. That's why this is crossed out for the common name. There is no common name for this. Now we need to find chromate. Chromate is a polyatomic ion. It has a 2 minus charge. So let's find that over here. We have chromate. Chromate is in that 2 minus category, and we are going to highlight that ion. That is CrO4 2 minus. CrO4 2 minus. So that's CrO4 2 minus. So we're going to circle the cationic charge, circle the anionic charge, cross out the plus, cross out the minus. We're going to take the bull by the horn, flip, bring it down. That 2 comes here. This 1 comes here. So I'm going to write K and a 2, CrO4, and parentheses with a 1. Again, that 1 does not belong there, and then consequently the parentheses do not belong there. So the formula is simply K2CrO4. All right, awesome. We have another one to do, so we're going to slide this up just slightly here. So hopefully you have remembered that we have our systematic name first, common name, and then our formula of our compound. So our next one is copper with a Roman numeral 2 and then permanganate. So that means that with this Roman numeral 2, again, if you know your Roman numerals, which you should, this is a 2 plus charge right there. All right, fantastic. So I need to find copper. If it has a Roman numeral, then it must be a transition metal cation. So I'm going to look in the transition metal cation section. That's right here in the middle of my ion sheet. And it says copper Roman numeral 2. So copper Roman numeral 2 is right there. That is called cupric as a common name, and it is, of course, Cu with a 2 plus charge to it. Okay, so that's a Cu with a 2 plus charge, and that's cupric, Cupric, and then permanganate. Perfect. By the way, just a real quick little break. You are watching The Crazy Hat Chemist, and please watch my videos on YouTube. I would greatly appreciate that. Like and subscribe. Another little hint is if you are enjoying this ion sheet, so if you see this ion sheet, this charges on ions and oxidation numbers, then send me a comment in that section there on YouTube. Send me a comment and with your email and say, Crazy Hat Chemist, can you please send me your ion sheet in a PDF format via my email? Here's my email and I'll send it to you. All right, cool. All right, now we need to find permanganate. That is a polyatomic ion, and so we need to find that, and that will be right here in, let's find that name. It's permanganate, and then that would correspond to MnO4 with a 1 minus charge. So that is MnO4 with a 1 minus charge. I'm going to do like what we did before, circle the cation, circle the anion, cross out that plus and minus charge, take the bull by the horn, flip, bring it down, and you will have the following. It's a Cu, and then there's a penciled 1 that does not belong there, MnO4, and then there is parentheses, and a 2. Excuse me. Trying to hold that sneeze back, but it just didn't happen. It is allergy season. Sorry about that. All right, so hopefully you got that one, and let's move on to the next one. So the next one here, I actually have a common name. It's cuprous arsenate. So I need to find Since this has an ending here with an OUS, I know it is the lower of the two charges. And just as a hint, we just did Cooperic, and here is Cooperus. So it's going to be in the same section. It's the same element. Hopefully you get that. And so where is Cooperus? It's right here, Cooperus. And that corresponds to what? None other than copper Roman numeral 1, and that is a Cu with a 1 plus charge. Perfect. So I'm going to write that down. That's going to be a Cu with a 1 plus charge. Okay, and then we need arsenate. Arsenate is a polyatomic ion, and it is in this lower section right here. Right here, arsenate, and that corresponds to ASO4 3 minus. Okay, so let's write that down. ASO4 3 minus. So just a reminder here, that's copper Roman numeral 1. So I'm going to write that down, copper Roman numeral 1, and then arsenate. All right, now we need to come up with the formula. All right, so to come up with the formula, like I did before, like we've done before, I'm going to circle the cationic charge, circle the anionic charge, cross out the plus, cross out the minus, take the bull by the horns. That's a 1, that's a 3. Flip the numbers, drop it down. So that 3 is going to come here, that 1 is going to come here like that. So I will have the formula of Cu 3 and then ASO4 and parentheses and a 1. And again, remember, you are not writing that parentheses or the 1. It is there, like imagine it, but it is not there. So let's scroll this up a little bit more so that we can get some more done on this. The next one here is plumbus chlorate. And again, this has an OUS or an IC ending on it, so it's going to be a transition metal cation. Let's see if we can find that. So plumbus is going to be here in our transition metal cation category. There is plumbus, and that corresponds to lead Roman numeral 2, which is a Pb2 plus. Okay, so I'm going to write lead Roman numeral 2 chlorate. And that is a Pb with a 2 plus. Now I need to find chlorate. That is a polyatomic ion. That is in the 1 minus category of our polyatomic ions. Now be very careful here. There is a hypochlorite. There's a chlorite, chlorate, and a hyperchlorate. So you need to be very careful that you're picking the correct one. This is chlorate, which is ClO3 1 minus. So that is ClO3 1 minus. Again, we're going to take the bull by the horns with circling the cation and the anion, crossing out the positive and negative charges. Take the bull by the horn, flip those numbers. I'm going to have a Pb, and then there's an imaginary dashed 1 right there. I'm going to have ClO3, and then a parentheses with a 2 on the outside, just like that. Perfect. Beautiful. We're looking good. I hope you're hanging on. We're not quite halfway done, but we're getting pretty far. Sorry about this. Got those allergies going on. Here we go. Nicolic oxalate. So it has an IC ending, so that means it's a transition metal cation. I need to find nicolic. Nicolic. And nicolic is right here. Nicolic, and that corresponds to nickel Roman numeral 3, and that is Ni3 plus. So we're going to write down nickel Roman numeral 3, and then oxalate. And that is an Ni with a 3 plus for nicolic. And now I need to find oxalate. That is a polyatomic ion for oxalate. That is in the 2 minus category here. So here it is. There's oxalate, and that corresponds to the following formula, C2O4 2 minus. C2O4 and a 2 minus. And just like before, we're going to take the cationic charge, cross out the plus, take the anionic charge, cross out the minus, take the bull by the horn to flip, bring it down. That's a 3, that's a 2, 2, 2, 2, 3 and a 2, 3, 2, and flip and bring it down. And that 2 comes up over down here. That 3 flops down over there. So I'm going to have an Ni with a 3, and then C2O4 parentheses. Whoops, sorry, I apologize. This is a 2, and this is a 3. There we go. That's better. Sorry about that little correction there. So just to make sure that 2 comes here and that 3 comes there. You do need the parentheses since the number outside the parentheses is greater than 1 and it has not been reduced. All right, let's scroll this on up here and see what we can do. Our next one here, we have a name of cadmium phosphide. So I'm going to find cadmium, and notice that it does not have a Roman numeral. So that means it's a periodic trend, and we can find it right here. As we discussed earlier, there's cadmium. It's a 2 plus, and it is a CD. So that is a CD with a 2 plus, and you can also find that in the 2 plus category of the monoatomic ions, of the monoatomic cations, that is. It's italicized because it is a periodic trend. It's in the 2 plus category, all right? Now I need to find phosphide, and phosphide is actually a monoatomic anion. It's in the 3 minus category. There it is, phosphide, and that is P with a 3 minus. Make sure you don't confuse that with phosphate or phosphite. There is a single letter difference in spelling, and it does matter. So this is phosphide. Is there an alternate name for cadmium? There is absolutely not. So this is actually going to be crossed out. I'm going to take the cationic charge, circle it, cross out the plus, anionic charge, circle it, cross out the minus, take the bull by the horns, flip these two numbers here, and I'm going to have the following formula. That's CD and a 3, and then P and a 2. There is no parentheses because there is no polyatomic ion. All right, we're about halfway done. Now we need to keep on scrolling and keep on moving. So what we're doing now for the remainder of this worksheet is we're going to be going backwards. So we're going to be starting with the formulas that you see on the right-hand side. We might be writing common names in the middle, but we most certainly will be writing systematic names on the left-hand side. So let's see if we can nail this down. So what we're going to do this time is just do exactly the opposite of what we have been doing. What we have been doing is taking the bull by the horns, flip, bringing it down to write the formula. What we're going to do this time is we're going to take the bull by the horns and flipping and bringing it up. So I'm going to highlight some numbers here, and we're going to take these numbers. That's a 2 and that's a 3. That 2 is going to come and flip and bring it up. This 3 is going to come flip and bring it up. This is going to help me find these. So that means that I'm going to have a CO that's a 2 plus charge. Excuse me, a 3 plus charge. And I'm going to find a CO3 that is going to be a 2 minus charge. Okay, so you see that this CO will have a 3 plus charge, boom, and this CO3 will have a 2 minus charge. So I've written that down right here for you. So you can see that that's a 3 plus and a 2 minus. Okay, now there is not an X'd out section, so that means that there's probably a common name for this, for CO. So we're going to find that, and that is one of these transition metal cations. It's a 3 plus for that CO. It's a CO that's a 3 plus, and that corresponds to cobalt Roman numeral 3, and it corresponds to cobaltic. So we're going to write those two systematic and common names. So the common name is cobaltic, and the systematic name is cobalt Roman numeral 3. Now, what I need to do is I need to find, for example, I need to find this polyatomic ion. So this is a polyatomic ion because it has more than one capital letter, but I can find it in that 2 minus category. So I'm going to look in this 2 minus category. That's right here. I'm going to be looking in this small section. So I've really narrowed down my focus. I'm looking in the 2 minus category. I'm going to find CO3 with a 2 minus, and that is called carbonate. It's that simple. So CO3 2 minus is carbonate. So it's cobaltic carbonate or cobalt Roman numeral 3 carbonate. Perfect. That is our next one. All right, so let's see if we can continue on this beautiful, wonderful process. So now on this last problem, we had parentheses. We actually have parentheses around this polyatomic ion and parentheses around this polyatomic ion. If the numbers are not there, then we're going to place numbers. There's a 1 and there's a 1. I'm going to take this number, flip and bring it up. Take this number, flip and bring it up. So what will I get as far as formulas? I will have NH4 with a 1 plus, and then I will have CH3 COO with a 1 minus. This should help me. Now, I do know, and I can see, that this is a polyatomic cation, and there is only one polyatomic cation, and that is right here, and that is the ammonium ion. So I'm going to write down ammonium. Ammonium corresponds to NH4 with a 1 plus. Now I need to find CH3, COO, 1 minus. And the hint here is that it is in the 1 minus category. So I'm going to find CH3, COO, 1 minus, and that is called acetate. The other way of writing it is C2H3O2. That's a condensed formula with the 1 minus. So it's called acetate. So ammonium acetate. It's that simple. Done. Piece of cake. All right. Scrolling this up for just a little bit here. Let's see what we got. And this next one here, we're going to take this number that's right here and this number that's right there. I'm going to highlight those two numbers. There's a number here and a number here. Okay. This number that's in this circle is a 1. I'm going to take it and flip it up, and then I'm going to take this number and flip it up right over here. So I'm going to have an AL with a 3 plus, AL with a 3 plus, and then I'm going to have an OH with a 1 minus, OH with a 1 minus. Again, this really helps me to find where these ions are. This is in the 1 minus category. It's a polyatomic ion. This is in the 3 plus category, and so I should be able to find these. So the first one, that's the cation, is in the 3 plus category. So the 3 plus category is right here. So it's in this rectangular box right there. It's a AL with a 3 plus, and that is called aluminum. So the first word that I write down is aluminum. ALUMINUM, that's aluminum. Then I need to find an OH. This is a polyatomic ion because it has 2 capital letters. It is in the 1 minus category. We've actually found this before and used it before, and that is OH 1 minus. That is called hydroxide. So we'll write that down. So the name of this compound is aluminum hydroxide. HYDROXIDE, hydroxide, aluminum hydroxide. Perfect. All right, scroll this up just a little bit more and just a quick little advertisement break. You are correct. You are watching The Crazy Hat Chemist, and please watch my videos on YouTube, like and subscribe. And like I said, if you want that charges on ions and oxidation numbers sheet of paper, then send a comment in the comment section and give me a like and send me your email, and I'll send you that as a PDF. Okay. So this next one is an Na2. I'm going to circle that number, and then I'm going to circle this number, and that is a 1. So I'm going to take this highlighted number 2, highlighted number 1. I'm going to take the bull by the horn, flip and bring it up. That will give me an Na with a 1, and its cations always come first. That's an O with a 2, and anions come second. So Na, that is in the 1 plus category. It's a monoatomic ion, and it is right here. It is Na1 plus, and that is called sodium. So I just write down the word sodium. Sodium, it's that simple. All right. And then what we're going to do is we are going to find this thing that is an O with a 2 minus. It's also a monoatomic ion, not two capital letters, so it's monoatomic. It's in the 2 minus category. It's O2 2 minus. It's O 2 minus, and that's oxide. So it's that simple. It's sodium oxide. Perfect. And then the next one here is a Cu. There's a number right there. And this is a polyatomic ion. So I'm going to place that in parentheses with a number right there, like that. Okay. All right, perfect. And so what's this number? That's a 1. What's this number? That's a 1. So I'm going to highlight both of those. That's a number 1. That's a number 1. Okay, I'm going to take the bull by the horn, flip that, bring that number up. That's a 1 minus. Take this number, flip it, bring it up. That's a 1 plus. So what I have is a Cu. That's a 1 plus. And then I have an IO2 and a 1 minus. So you notice that this is not X'd out right over here. That means that this probably is a transition metal cation, the Cu1 plus. And we've played with this one before, even today on this worksheet. Transition metal cation, that's a Cu, and that is a 1 plus. That's copper, Roman numeral 1, and cuprous is the common name. So cuprous and copper with a Roman numeral 1. Now I need to find IO2 1 minus. And of course, this 1 minus should highlight me as to where I need to go. I need to look at my polyatomic anions. I need to look in the 1 minus category. I'm going to find IO2 1 minus, and that is called iodite. Iodite. So it's cuprous iodite or copper Roman numeral 1 iodite. Perfect. All right, let's keep on going. We only have 3 more problems left to do. There's a number right here. That's a 1. There is a number right here. I'm going to highlight these 2 numbers. I'm going to take the bull by the horn, flip, bring it up. That number comes up here. That is a 1 minus. This number comes up here. That's a 2 plus. So I have a Zn with a 2 plus and a Cl with a 1 minus. So that Zn is a is a cation, and it is a periodic trend, and there it is, Zn with a 2 plus. That is zinc. You can also find it in the 2 plus category of the monoatomic ions, and that is Zn 2 plus, and that is zinc. So I'm going to write down the word zinc. Zinc. And then Cl1 minus, that is actually a nonmetal. It's a halide ion. It is right here, Cl, and in this column is a 1 minus for this entire column, and that is chlorine. That is the element chlorine. However, it's also right here, and I would defer to this, and that's in the 1 minus. That's a Cl1 minus, and it is an ion of chlorine, so it's called chloride. Perfect. There we go. All right, so we only have 2 more left to do. And just as a reminder, you are watching The Crazy Hat Chemist, where you learn the proper chemistry. All right, so here we go. We are going to highlight this number and highlight this number. Those are the 2 numbers. I'm going to flip and bring it up. That will give this a 3. That will flip and give this a 2. I'm going to look for Mn, that's a 2 plus, and I'm going to look for BO3, that's a 3 minus. Apparently, since it's not X'd out, there is a common name. So I'm going to find Mn2 plus, and that will be in the transition metal cations. And here it is. Get that pink highlighter. It's a 2 plus of this. And so there's 2 plus, and that's called manganese 2 or manganese. So I'm going to write that down for the common name and the systematic name. Magnesium, sorry, manganese. Manganese. That's Roman numeral 2 because it has a 2 plus charge, or manganese. And then now I need to find this polyatomic ion that's in the 3 minus category. So I'm going to look in the 3 minus category, and I'm going to find this polyatomic ion, BO3, in the 3 minus category, and that is called what? Borate. That's right. Borate. Perfect. Now I have one more to do. I'm going to take this number right here, that 3, and that 2 right there. I'm going to take those numbers and I'm going to flip them. So this will be a 3. Flip this number, that will be a 2. I'm going to have an Mg that's a 2 plus because it's a cation. I'm going to have an N that's a 3 minus because that's an anion. So now I need to find none other than Mg that's a 2 plus. So that is going to be right here in the 2 plus category. 2 plus category, and that's Mg with a 2 plus, and that's called magnesium. So I'm going to write the word down, magnesium. Very different than manganese. Magnesium and manganese, very different. Now I'm going to look in the 3 minus category. 3 minus category, I'm going to find the N3 minus, and that is called nitride. That's right, nitride. All right, that's fantastic. So just quickly again, you are watching the Crazy Hat Chemist, and this is the place that you get all your chemistry needs met. I hope you've enjoyed this video. Please like and subscribe. Send me some comments. I greatly appreciate that, and I hope you have a fantastic day. I will see you next time for more videos. Bye for now.